So welcome everybody to ficonTEC's mini webinar series. This is episode 4. Today we will be covering the topic of artificial intelligence and machine learning based process control. So what are the implementations and applications of that technology at various levels within ficonTEC and within the ficonTEC systems, both on an R&D level, on a collaborative project level with other partners, and also in an industrial setting. My sparring partners, my assistants for today, if you like, first of all, Dr. Colin Dankwart from R&D. Hello, Colin.
Hi, Greg. Good to see you.
Good morning, or good afternoon for you in this case. And also Dave Pritz from industrial partner Adaptix, based in California in the US. Dave, good morning.
Good morning, good afternoon.
I understand it's very early in the morning for you, right?
It is very early in the morning.
You have your coffee ready.
I do have my coffee, as you can see. I'm ready.
Okay, very good. So if we move on to the next slide, please then, Kevin. So a quick reminder of what this is all about. So we have a mini webinar series running in Q4. In the even calendar weeks, we will be addressing product related topics. And in the odd calendar weeks, as this week, we will be talking about technologies. The schedule in the different calendar weeks is illustrated on the left. We had a hiccup due to lockdown issues last week. The topic of bond line and custom line product lines will now appear in calendar week 48, so that is next week. Other than that, most of everything else has remained the same. Today's topic remains as originally scheduled. Next slide, please, Kevin. With the events cancelled, what is it that we are now trying to achieve? We want to try and maintain the dialogue with people who we would normally meet at events. This is effectively an additional channel to LinkedIn, to the website, and to other traditional forms of communication. But we are well aware that this is now a well-traveled channel, the video channel. Zoom fatigue is becoming a common phrase amongst those that suffer from it. So we offer here a series of bite-sized seminars. We want to keep them short, so we want to keep the core topic to something like 20 to 30 minutes. This has 2 or 3 maybe potential advantages. You can come to these guilt-free because you can leave within 45 minutes, maximum an hour, and get back to work to get things done. It is also an agile format, which means that we can up our game, we can improve our performance, and we can change the topics to suit demand and current interest. What you will see with these webinars is there will be a giveaway, which I will do in a moment. We will talk about news and developments, and then there will be the core topic of the webinar. And the current format is that we will try to make each slide a discussion format in its own case. And we hope that to have some questions coming in over the chat from the viewers that we can either try to integrate within the presentation or certainly have a question and answer session at the end of the presentation about the core topic. Okay, so Kevin, next slide, please. So this is to remind me to not forget the giveaway. If we, Colin, I think that is sitting in front of you on the table, maybe you can point to it. So we have a cup and a couple of other minor ficonTEC giveaways lined up for somebody who can best answer this question in the chat during the webinar. That question is, what is the standard clean room classification for our systems? So this time you need to look on the website, the ficonTEC website, and try and find out what that clean room classification is. Write the answer down into the chat, and the first person to do that correctly will win this week's giveaway. Okay. So we have some news items of what has happened in the intervening period since the last webinar. The most important 2 news items, or 3 news items, I guess, if you like, we are investigating, we've been working some time on wafer level testing systems, making a number of considerations and giving a lot of thought and development into how those systems need to look like moving forward, speaking to the players on the market. At least one of those activities has become visible. This is with VLC Photonics based in Valencia in Spain, who are in the process of taking ownership of a wafer level material system independent machine system, and that will be delivered in the very near future. More or less in the same week, the news there with regard to VLC is that Hitachi High-Tech have taken over the company. I believe VLC will be continuing in its own right as an autonomous entity pursuing its activities, but this enables Hitachi to have a vested interest in the photonics device market, which I think is a win for all of us. Something else happened this week is that there was one of the regular and very valuable EPIC OTM meetings. The topic this week was on PIC testing, so double relevancy here. And our legendary business development or ex-business development guy, Ignazio Piagentini, who has been heading up the testing department for the last year and a half, presented the viewership there with a number of questions and considerations and put out the request that we put together a working body moving forward to tackle this issue of wafer level testing and what exactly needs to be done to deliver the best systems to the market. You can find further information about those news items on LinkedIn for VLC, for example, with EPIC, then on their website and also on their YouTube channel, where you will find but past recordings of previous OTMs. They also have a lively calendar moving forward. Every Monday, something usually happens. We have an answer to the chat. Apostolos Krondon Asios at core. I assume he's somewhere in Southern Europe. He might tell us on the chat where he's exactly located, but he has come up with the correct answer. ISO 6, well done, Apostolos. So that means you will receive the giveaway. If you can drop us, well, we have your email address. We will use that to contact you and find out your address in Greece. Thank you very much. We will use that to contact you to make sure we get your address and send you that giveaway. Thank you for your response. So at this point, we'll move on to the topic we want to present. And that topic is about the artificial intelligence or machine learning based process control and where that infringes, where that interacts, where that is visible in our activities and also within our systems. An initial point perhaps is let's be clear about this, the application of AI and LL machine learning is not strictly new. All you need to do is refer to Industry 4.0, for example. What we are presenting here is the realization of the benefits for photonics assembly and test applications. Again, not only in a lab or an R&D environment, but in a real many machine, real world industrial setting. Through this work, we are realizing not only benefits for individual customers or individual hardware items, but we are effectively helping the evolution of our machines, so benefiting the potential customer target audience in general moving forward. At this point, I will be handing over lead to Dr. Colin Dagwart from R&D, who is our specialist, an expert for leading us through this topic and answering questions. Colin, lead on, and thank you for your time.
Thank you, Greg. Okay, I would like to start off with explaining a few terms that we use here. I think these things are often used improperly or not explained properly. And so the main umbrella term that we're talking about here is artificial intelligence. And let me read out the definition of intelligence, artificial intelligence, as you find it online, is this study of intelligent agents that is any device that perceives its environment and takes actions that maximize its chance of successfully achieving its goals. So as you hear, this is a very wide scope of different applications and different approaches to those applications. And for an industrial environment, it is typically too wide of a scope. What we have in an industrial context is more a narrow scope and a specific problem that we're trying to solve. And for these applications and for these use cases, machine learning most of the times lends itself better to solving these problems than other artificial intelligence approaches. So machine learning is the study of computer algorithms that improve automatically through experience. And by experience, we mean data. It is seen as a subset of artificial intelligence. And these algorithms build a model based on sample data in order to make predictions or decisions without being explicitly programmed to do so. So basically, machine learning is really data-driven. And in contrast to classical approaches like just a simple regression or any of that, the heuristics basically evolve around how the data is used to generate a certain output, and not so much about the problem itself. So it's as long as you have the data, the overall approach is pretty much agnostic to how the structure, how the problem is structured.
Colin, can I ask a question at this point? So something I picked up a little time ago, it may have been on Wikipedia, I think. I picked up an alternative definition for artificial intelligence, and that was anything that has not been done yet with a computer.
Okay, yeah, I heard about that too, and I think it fits to a degree because basically what you would have considered artificial intelligence about a decade ago, by now it's sort of a standard, and people don't actually think that this is particular intelligent, where in contrast to where it was new. So I think there is some truth in that, and if you look at the development of and the impact that artificial intelligence has made, like for instance the Google AlphaZero chess machine that just beat every other machine in chess. This is really having an impact on how people perceive artificial intelligence. So yeah.
And I think more importantly in how to address the problem, right?
Exactly. As a subset of machine learning, we also have deep learning. We will touch upon that briefly later on. So yeah.
Okay. One more question from my side. So in general, is there for the audience and for the target audience that we would normally want to address, what is a typical justification for applying machine learning in a machine system environment?
Yeah.
What is it you want to achieve?
I think that is very dependent on the use case. In some instances, you can actually make a machine completely autonomous for solving a particular problem. So if the machine can identify that it has to be calibrated, and we implement an automated calibration routine, there's no need to involve the operator in that. And so it actually really depends on the use case. If an operator or a technician is required, then the use case would be to identify the problem and send out an email to the technician.
Thank you.
Okay, next slide, Kevin, please. All right, so we actually have a multitude of different applications of machine learning at ficonTEC. So not only many different applications, but also many stages of the development where we use it. By the way, the active lens alignment that you see here, that would be one of the topics here. So pay attention. As I said, the alignment of lenses is one of these. So the general term I would use is passive alignment of optical elements. These can be lenses or a camera assembly. The second topic that I will also present is adaptive motion control, which is based on an autonomous machine. And we have the inspection of parts via deep learning. Also, and this is the part that Dave will mostly present, we have the predictive maintenance approaches where machine learning is an essential to its success. Last but not least, we're actually involved not only in R&D and together with Adaptix in these topics, but also in larger scale European projects, publicly funded projects like iQonic. And I think I already saw in the chat that we have one member of our iQonic in the.
Just for information, I'm hoping that we're going to be able to include different R&D projects within the webinar series at a future date, so moving into 2021. And I believe we are already talking to the iQonic group about how we can realize that in 2021. So that is when we will return to that topic. I have a question, or I have a comment. I guess what we're looking at here as well, Colin, correct me if I'm wrong, is we're looking at different levels of what is telling what exactly to do. Yeah. Some of it is autonomous, some of it is learning for our own benefit. Is that correct?
Yeah, absolutely. If you look at the topics we have here, for the first topic, we mainly used machine learning to understand what the data is telling us. The solution doesn't necessarily have to be machine learning based, but there's incredible value in actually using that for data exploration and visualization also. And if that can also be used for solving the problem, that's even better. But sometimes there's incredible value only in making data visible. Okay, so I think I'll start with the first topic. Okay, so the first topic that I'll cover here is the passive alignment of fast axis collimation lenses for laser diodes. And I think most of my audience will already know what this is about. So you have an edge emitting laser diode that requires different lenses for different axes because of different divergence properties. What we typically use for these kinds of alignments is what we call a beam characterization tool. It's basically a camera that looks at the beam, and by analyzing what the beam looks like, we can tell if it's already collimated or not. And so the difficulty here is really that we have a total of 6 degrees of freedom that we can align, because the system is overall sensitive to variations in the components, etc. The passive alignment is really not completely sufficient to tackle this. So we have an active alignment with 6 or rather 5 meaningful degrees of freedom. So this can actually be time consuming, and well, time is money. So we actually want to make that a lot faster, and in the process probably even more accurate.
If I can add, Colin, we had the topic of passive versus active alignment in the previous webinar. I think that one was with Dr. Simon Kibbin from R&D as well. That occurred 2 weeks ago, and that is available via View on Demand. So we won't want to go into detail about exactly how those processes proceed within the system. But the basic information is that we have a 2-step process here that should remain as a 2-step process, but we want to try and realize maybe time savings to enable higher throughput. Is that correct?
Exactly. Yeah, that is correct. So yeah, next slide, Kevin, please. So what we actually did is first of all, we wanted to analyze if we can use the data that we have before the active alignment in order to predict the outcome of the alignment, which essentially means that we can just skip parts of the alignment. What we did is actually we used machine learning to calculate if we can actually see some clusters in the data. First of all, I want you to pay attention to the purple cluster. On the x-axis, you see basically it is a measure of the beam width, and on the y-axis you see the displacement from the ideal focus position. So this is the difference in focus direction between before the active alignment and after the active alignment. So basically, what we wanted to do here is to be able to predict the outcome of the active alignment, so that we can just skip it, basically.
Is that correct? Is that correct, Colin, that you want to skip it, or you want to actually be able to predict an initial, a better initialization status?
Yeah, you're right. Well, ideally, we would like to skip it, but in practice, some part of the active alignment is really essential. And so we still do an active alignment, but it only optimizes the last, like, say, 5% of the alignment. Yeah, what you see in the purple grouping is basically what we would expect there to be, where the further away you are from the actual focus position, the wider the beam is. So yeah, and this is already the main result of this analysis, that we can actually predict the ideal position of the lens based on a measure for the beam width. Now, the second outcome of that analysis was that we actually have a group of systems where this did not actually work. Basically, the explanation for that is that the beam width could not be properly measured, basically because the lens is too far away from the focus, so the beam becomes very wide.
What machine learning has provided us with an unexpected level of data visibility. We see a second group here, albeit smaller, but we see a second group here which is indicating an unexpected behavior that we weren't expecting. Exactly. And we are now in a position to do what with that data?
Based on that data, we can predict where the focus position should be, and from there we only start a fine alignment of the position, and thereby we can save about half of the alignment time. So
okay, but there's potentially a second win here, isn't there, as well, right? Because if you can save time with the purple data, that is quite clear, I think, to everybody. But now understanding that there's a second group, you're in a position maybe to look at the constellation of the hardware and system approach to that particular problem, and maybe change the initialization of that process so that you minimize the second group and everything falls onto the purple curve.
Yeah.
So exactly. You save even more time.
Yeah, precisely. So we can make sure that we approach the problem so that we basically eliminate the yellow group too. Yeah.
Okay. This initial step is a passive approach. So I guess that common expression is your mileage might vary depending exactly on what your hardware and component constellation is. If the components have different tolerances in terms of what the recognizable features or geometrical features are that are used for the passive alignment, that would change the constellation slightly and then maybe change this grouping.
Yeah.
Okay, thank you.
Okay, next slide, please. Okay, so to our second implementation here. So let me begin by explaining how a motion system in our machines is typically configured. So during the commissioning of the machine, we optimize the motion parameters so that it fits the application of the customer. So, and during the programming of the machine, this is further refined, and when the machine is delivered to the customer, we can make adaptations and make sure that this system performs really well in the environment that it's placed. However, if anything in the environment changes, this might actually have an impact on the system. So by environment, I also mean if you place additional load on the axis system, if you have any wear on mechanical parts, or even have to replace a mechanical part, overall the motion system will act differently. So the difficulty for us is those things cannot be properly predicted, and so we actually came up with an approach where we could optimize the motion system autonomously. So basically, the motion system optimizes itself. And how this works is that we gather a lot of data about the actual performance of the motion system. So we have position errors, we have the outcome of the alignment, and we have other parameters of the process that is running. And by using EdgeOps, which is the Adaptix software platform, we analyze that data and update the motion parameters in order to correct for different environmental changes. And by doing this, we can basically have the system adapt in a way that it hits that sweet spot between speed of the motion system and the accuracy that is required for the customer components. So basically, there is always a trade-off between the two, and by analyzing the data that we get from the actual process, we can make sure that we stay in that zone where to hit the UPH goals of the customer. And okay, so next slide, please. So what you see here is motion parameters. I will not disclose which motion parameters these actually are. How we configured this system is that the motion parameters are increased until a certain error threshold. If you look at the three different curves, these are for three different axes. The green curve has already converged to its optimum configuration, and the blue curve, which is the z-axis, you can see it increasing until it hits a certain threshold, and from there it stays constant. So what I want you to take away from this slide is that by changing the motion parameters, we have control over the motion error that we allow, and we can actually control this in a way that is adapted to the
task, I imagine.
Yeah, exactly. So it's specific to the customer components. Okay, next slide.
Can we go back a slide, please? I have a couple of questions here. So I imagine this parameter set looks very different depending on, or rather this motion system optimization process looks very different depending on the exact task that your motion system has to carry out, right? If I think of pick and place on the one hand, and then think of passive optic alignment on the other, those are very different motion requirements.
Absolutely, absolutely. And yes, we actually use different settings for different phases of the assembly process. And yeah, so for the active alignment, when you have any vibrations in the system that could affect the alignment, we need to make sure that these are within certain boundaries. Whereas for pick and place, the position errors of other axes during pick and place is not that critical. As long as the part reaches its destination, we're basically good.
Okay. And my other question is so what we've learned here is that the hardware, or rather the system control, can exercise a degree of self-maintenance to avoid changes in performance, to maintain performance over a longer period of time, depending on the changing environmental aspects. But how is this actually applied? How is this applied in a real world situation? Who gets to see this and how?
If someone actually wants to look at the data, they can. But since the system is actually doing this autonomously, there's no requirement for actually analyzing the data on a daily basis.
So this means edge ops is running full time. Do we also maybe use this step as before systems are delivered, where edge ops is not part of that installation package?
What we actually do is we have a very similar process during the commissioning of our machine. So we actually employ the same principles. The process looks slightly different, but it actually is very, very similar.
And I guess the final aspect about this is that this is not only something that happens necessarily at the customer side, right? If edge ops is running, and Dave will correct us on this, I believe, this means that we also have some degree of visibility, if that is allowed, and also on these stages that occur where edge ops is not a permanent installation, then I guess we are continually learning about our hardware and what the boundaries are for the performance of that hardware is. That's adding to our knowledge base. Okay.
Yeah, and Greg, I'll go in a little more detail in my slides, but this is a very exciting advancement between ficonTEC and Adaptix, right? So really being able to control motion and adjustments from anywhere, right, at any time. And really the only time a machine would need repair is if you actually had something break on the machine. So I'll highlight that a little bit more in my slides.
Very good. Thank you, David.
Okay, so here we see a video about our visual inspection, and this is based on a deep learning approach. So we actually have a neural network with several layers in it, which is the definition of deep learning, and we use that in order to classify images of possible defects or good parts. And the nice aspect, or one of the nice aspects of this approach, is that the main work is basically assembling images and putting them into different folders corresponding to the different categories of defects or good parts. And if that data is present, all you have to do is have the neural network learn based on that data, and thereby you can extract the network and apply it on your machine. And so the outcome of such a classification is not only the classification itself, but you also get a confidence value. So the neural network basically tells you with which confidence it actually identified a defect or not. And so by thresholding that confidence, you can not only make sure that your system is very robust to different changes, but also you can make sure that those images where you're not confident in, there you can still use human intervention, but overall this is a very good approach to make the inspection very robust.
You say inspection. I don't think we've actually heard exactly of what.
Okay, so this is actually inspection of different optical or mechanical components in general. So in what we saw in these images was a surface with two V grooves for fibers. And so this is one example of a component that we would inspect. But generally, everything that is prone to have mechanical defects that are difficult to identify, those are the cases where we can use visual inspection very well.
So cracks, debris, misformed components, I imagine it could be die facets or chip facets equally as well. Is that correct? As long as you have that data set of imagery that allows a classification into different defect types.
Exactly. So,
including good images as well, of course.
absolutely, you do need a lot of good examples, and well, if your fabrication is going well, you should have that data anyway.
Okay, thank you. I believe we're at the end of your contribution, not entirely, but you are, of course, welcome to continue in the conversation. But at least in terms of the slides that you are presenting, I believe we're at the end. So I guess at this point is we want to try and make a transition over to what Dave from Adaptix then is going to present. And at this point, I guess the question we need to ask then is so in a real world application scenario, what is the benefit for the end user? So far, we've been looking at efforts within R&D to better understand hardware, parameter, device combinations. But to an extent, as already mentioned, these are sort of constellation specific, and your mileage might vary depending on your exact constellation. Naturally, there are general lessons that can be learned here about process optimization scenarios that can be broadly transferred to customers, into the machines, and to our database, to our knowledge base. And what we've done so far in each of these examples, we've used the data visibility that has been provided by the machine learning interface to provide insight, to show groups of data that maybe we hadn't expected, and that having that knowledge, then we are then better equipped to maybe to rewrite or refashion the process and the parameter matrix so we can achieve a better ROI for the operator. So how does this look like in a real world installation? I've already mentioned that or it's already been mentioned that we have the access to Edge Ops. Edge Ops is provided by Adaptix, and it is there, and Dave will correct me here if I'm wrong, it's their artificial intelligence, machine learning, data acquisition platform interface.
Yep.
But as I said, I'm sure Dave is now the person to lead us on through the next couple of slides. Dave, please go ahead.
Great. Thank you, Greg. And again, thank you to ficonTEC, right? We appreciate the relationship and the opportunity to share kind of the great collaboration our teams have done together. So Kevin, let's go next slide. So we talked early in the presentation about how critical data is to any machine learning, right? And more important than that actually is getting real-time data capture, right? And once you have the data, right, you're then able to train the models, you're then able to make adjustments, and you're able to drive and improve performance and quality. So I have a couple of slides to kind of walk through that process. But really you can see here on this slide, ability to capture and integrate directly with the PCM on the ficonTEC equipment, the process control master. So in the past, whether it was a visualization on the equipment or it was maybe an export to a CSV file, we really gave that immediate real-time ability to capture and visualize the data. So on the right side of the screen, you can see a customized dashboard, and we can customize these for any client engagement. With this client, it was final yield, it was first pass yield, performance level, and total UPH. And so we're really able to, again, in real time, capture, timestamp, and analyze the data. And once you have that, you can then train the ML models, right? You can then look broadly, and you can look remotely across any one system or multiple systems.
Dave, I have a question if I can interrupt.
Of course.
The protector in me wants to have a word here, and within PCM, which is our process control software, there's a degree of data acquisition that happens already. But I believe the Adaptix implementation is that you actually add to that system at several levels. Is that correct?
Yes, that is absolutely correct. And so not only are we streaming the data right in real time, we do augment with most ficonTEC pieces of equipment for external sensors. So you're then able to pick up heat, vibration, and other characteristics, and then present those as well in real time. So as you identify the critical parameters, you can then correlate different aspects that may be impacting UPH or ability to improve UPH, or correlations that may be causing quality issues. So I'll get into a couple of those examples in future slides, but absolutely the case is we're taking the data, visualizing the data, and augmenting that with additional sensors.
And I think one other thing we want to emphasize here is that this is not something that was initialized not even this year, right? This has been going on for some time. Can you give us a feel for how much momentum is behind this activity already?
Yeah, so great questions. So we've had great client adoption, right, and great partnership with ficonTEC. And most of you on the call or listening to this afterwards, there's a lot of pilots going on artificial intelligence, machine learning, or proof of concepts or pilots, and no one's really uncertain of ability to scale. Well, the great news is every proof of concept we've deployed has moved forward into some type of a production contract. But more importantly, one of our largest engagements with ficonTEC is deployed over 75 plus pieces of equipment. So you have the ability to scale the solution and really have a significant impact on a production line, both not only for maximizing UPH, but ensuring that there's any potential quality issues, you can get in front of those as well.
Are there any rules of thumb for application?
Yeah, so generally what we find, right, is anything that's high volume and low cost, right, in production, right? We do have a couple engagements on the R&D side, but that's more to work closely as you're integrating artificial intelligence and machine learning ultimately into the production. So I would say generally high volume, low cost, or high cost items, low volume, where it's critical that you're managing the quality, because to lose a potential part or not be able to deliver the right first pass yield would wind up creating complications and issues that would be very expensive.
Okay, thank you.
Let's go next slide. So here's a couple other ability, and again, very customizable dashboards. You can see the one on the left is similar to the first one. The one on the right, we work closely with clients and as well as with ficonTEC and identifying the right parameters to measure and monitor. And so this is all about, again, real-time data streaming. And I do want to highlight the fact that we are an edge-based solution versus a cloud-based solution. And really what the edge means, right, is a couple benefits. The data is secure. You're not sending the data out to the cloud. You have the ability of the amount of data we're gathering and analyzing, if you were to send that to the cloud, could wind up being very expensive, right? And also because we're at the edge, we're literally on the ficonTEC piece of equipment, you're able to capture that data in milliseconds. And I got a slide a little bit later on that highlights that. So we see a very significant advantage to being on site at the edge versus exporting the data out and then doing the calculations in the cloud and then sending that back in. The visual at the bottom center of the screen really allows you to compare multiple units, right, across potentially multiple geographies or multiple lines. So you would establish the key criteria you're looking, and you can see in this particular snapshot, you see first pass yield, you see UPH, and you set up thresholds, and we'd work with you to understand what those thresholds are. And green is obviously good. And then if you were to have one that would drop, and you can see there's a number there, I think it's 88% on the screen, that particular unit may be having an issue, and you're able to kind of go in and analyze exactly what may be happening with that unit.
Okay, and you had mentioned that this is to a large extent, or one of the main benefits is the edge operational aspect of this. But I think it's worth mentioning that this can also be viewed,
Yes.
can be viewed remotely.
Finally got that out. It's very powerful, right? You can view this access. A manager could view it, or process engineer remotely. They could view it from home. You could view it on your mobile phone, your mobile device. You could view it on your laptop. So you're able to provide visibility from anywhere. So if you had a remote manufacturing line, you're able to view that data in real time and get notifications in real time if there's a potential issue. So really trying to leverage the technology in a way that allows you to maximize, again, productivity of those lines.
Okay, and another aspect is that this doesn't have to be installed at system manufacturer, correct?
Correct. You mean on site?
Yes.
Yes. So correct. So we recently had success of being able to do a remote installation. So we actually preloaded our software onto the hardware components, the sensors. We had instructions. We shipped them to a location in Thailand. the manufacturer on site was able to do a complete installation in literally half a day. So this is very easy to deploy. We don't impact production because we already have the equipment pre-configured. We stream the data from the ficonTEC equipment and we can start training the ML models literally within a couple of weeks. So the installation process is very simple. We can do remote installation and then we start training the ML models literally once we get data within a couple of weeks.
And how long does that training phase last?
It's usually, I would say, let's call it a month, maybe. And anyone familiar with machine learning models know kind of the longer the models run, the more accurate they get, right? But initially, we're starting to stream data. We see that data immediately. We're then working with the customer in this case to say, hey, what does good look like on this? And let's go to the next slide. I think that's probably a little better visual. Thank you. So now that we have the data streaming, we have it visualized, we start identifying the parameters, right, that you want to be able to track, and then you start looking at what those anomalies are. So what you can see here on this screen, right, is kind of the orange dots, and then this anomalous behavior or potentially anomalous behavior. So we would work with the client, process engineers and others to identify, hey, we noticed that this happened and it seemed a little bit out of spec. Was there a problem on the equipment, right? And so turns out it's pretty good and a pretty good predictor of that. So back to your question, we can start training the models within 2 weeks. We start seeing results after maybe another 2 weeks, and then we start really deploying to kind of maximize the impact of the software.
Good, thank you.
Okay, let's go to the next slide. So this is a real world example, right? And I got the next slide after this is a couple more, but what you can see on the graph on the left is the blue is basically real-time data on the power readings on the optical power component. And you can see the line running across the middle, the green line is basically, that's the machine learning model working, right? It's saying, hey, things are good, everything's in order, no action needs to get taken. You can see a couple of red dots near the center of the screen, and that basically says, hey, you're having a little bit of an issue. It's not impacting production yet, but it may be in a position that it's going to start impacting it. You may get to a situation, you may have a failure that may lead to a quality issue or hard down and unscheduled downtime. So the red dashed line running through the middle of the screen is the notification process, and we work with you, the customer, to identify kind of what the right threshold is. You can see we then able to move in the line that kind of stair steps up. That's either a shift change, that's a pre-scheduled service call, or a scheduled call. And as a result of that, you can see the repair is made, and you can see the machine learning model is working again, showing to be green. So what's important here, prior to Adaptix, right? This machine would have run to either failure or until there was a quality issue. Now we're able to anticipate before there's an issue. As a result of that, you're able to maximize that. And then the other benefit is the technician coming to repair the machine actually knows exactly what's wrong with the machine. So not only are you reducing or eliminating unscheduled downtime, the amount of time to get the equipment back up and running again is minimized because there's no guessing. The technician knows exactly what part or exactly what needs to be adjusted. So very powerful impact on what we're able to achieve on this type of platform.
Okay, I think that's very clear. Colin?
I would have a comment. I think one additional benefit of this scenario is that you can actually schedule the repair when you actually have a technician present at the facility. So in the case where this part would break in the night shift and the technician is not there, you might actually have an entire shift of downtime for something that only requires 10 minutes to repair. So I think there's additional benefits in actually having that information early on that things are about to break.
Yep, I agree. Thanks, Colin. Good add.
So to a degree, I guess what we're seeing here is where we're seeing the utilization of machine learning to learn about the machines.
Exactly.
Okay.
Let's go to the next slide for a couple more examples. So similar application, right? In one of these particular clients, there's grippers, and everyone knows grippers over time, the gripper positions, and grippers need to be replaced. So we had a significant issue with one of our clients where they were uncertain kind of when the grippers needed to be replaced. So we built a machine learning model, and again, streaming the data, you can see kind of that green color. And then you can see the red dots are, hey, the gripper position is shifting slightly, right? And that likely means gripper's going to need to be replaced. In the past, you would have either scheduled it and replaced it potentially before the grippers actually needed to be replaced, or until there was a quality issue. And you can see the adjustment here, grippers were replaced, performance improved. And then on the lower side of the screen, same thing. You see the machine learning models trained. You can see the red dots saying that, hey, you're starting to have some variation that may impact performance and or quality. And then you can see the repair, and then you can see the machine learning model is working. So real world applications on how do you reduce or eliminate unscheduled downtime. And then when you do have the service call, exactly what needs to be replaced.
Okay, very clear. Thank you.
Next slide. So the other aspect that you get, and the other benefit, is really looking at each sub-process, right? And how long each is supposed to take. So this is a sample, right? And you can see on the right side of the screen, these steps, and there's about 30 steps in the process, and some of them take seconds and some of them take milliseconds. But what we're also able to do is looking at each sub-process step and building machine learning models where if each sub-step that wouldn't necessarily be observable by a human, you'd be in a position to say this process is starting to take longer, right? And as a result of that, what's going on, and you can really start to diagnose that. Or you can look to maximize your UPH. So we found significant improvements with several of our clients and working closely with ficonTEC that you're looking at adjustments, and maybe something that was supposed to take 11 seconds is now taking 20 seconds, right? That may be noticeable to a human, but you have the ability to adjust that on the fly. So we train the machine learning models to identify if in fact there is a slowdown, because that slowdown likely may be impacting quality and definitely is impacting UPH. So there's another aspect of this, is not only anticipating predictive maintenance and when you may need service, but also being actually look at how do you maximize the UPH to an issue that may be occurring.
Okay. So to a degree, I guess this is providing a sort of holistic level of visibility to the process or to the production as a whole, rather than focusing on anomalies appearing in individual hardware components.
Yes, and if there was a slowdown in a particular step, you would know exactly where that was occurring, right? And so as opposed to looking and say, wow, our UPH is slowed down, I wonder what could have happened. This gives you real-time access to say, hey, you know exactly what sub-process happened in real time.
Okay, good, thank you. That brings us to the end of the main topic here. I see it's obviously been for us at least, an interesting topic. We've overrun somewhat on time, but hopefully anybody who's not still around to see this content can watch it per view on demand at a later date. What we've seen so far is how AI and ML infringes or is implemented here at ficonTEC on several levels, who we are working with, and also that this activity has a measurable degree of momentum, and we are certainly not early learners in this field, so we have a lot to offer. And the essence of the message then here is if you have a potential production issue where you feel that machine learning may be able to help in problems that you have, or in general could be beneficial to the goals you have set yourself, get in touch, and we can sit around a virtual table and we can speak about what your requirements are and see exactly how this implementation can be useful for you. Last few comments from me. Again, as always, by these webinars, I'm going to point you to your principal source of further information. This is the homepage. As always, you will find direct access via icons to our LinkedIn, Twitter, Vimeo, YouTube channels. We also have a ficonTEC Insider blog page. You will find access to that from the menu. And of course, on our global locations page, you can find the contact addresses and telephone numbers for people in case you want to speak directly to somebody on the telephone or per Zoom or whatever your favorite channel of communication is nowadays. Those are your first points of call. Certainly the Insider blog and the LinkedIn and the Vimeo and YouTube channels are your most current sources of visual data or of news updates. You can discover about our products on our website. And if you have more questions, then there are opportunities on the website to reach out to us directly. I've mentioned the blog page. I've mentioned the event listings. There are some specific blog entries you might want to take a look at. And lastly, a final reminder here about the schedule, what sort of times of day these webinars occur at different parts of the world. Unfortunately for Dave, this was very early in his morning, but thank you indeed for taking part. I hope you had your copy to hand. The next webinar will be next week, and we will be covering products, bond line, and custom line again at 3 o'clock in the afternoon. So Kevin, if you can kill the presentation so that everybody can see us on the screen, then thank you very much. Thank you, Colin. Thank you, David, for your time. And of course, thank you, viewers, for tuning in. I hope that was useful to you. And I hope that will continue to be the case with future topics. Good day and goodbye.
Thanks, Greg.
Thank you.
Hey.
Bye-bye.
Bye-bye.